This is the aldehyde you see, carbonyl having a hydrogen. That's what makes an aldehyde. What we have on the other side is a methyl magnesium bromide. That is a strong nucleophilic Grignard reagents, right? So what we expect, this Grignard is going to make an attack to carbonyl because of carbonyl is electron deficient. When this makes an attack, these high electrons are going to go to oxygens. It's going to go to oxide. And at the end, when you're adding a water, because pick up the water, you get an alcohol. Pretty simple. So Grignard, the question can be simple like this. This is actually, the most simplest question you will ever get. The next one, you got the ketone, carbonyl having a 2-carbon chain, and then the ethyl magnesium bromide. So this is the nucleophilic end of the ethyl groups. That's the one that makes an attack here, and then it's going to make an alkoxide by pushing the electrons to the oxygens. The alkoxide will be waiting until you add the water in the second step, then pick up the protons, then you get the alcohol. Nothing really challenging, these two questions. Right? I'm pretty sure that when you see this type of question, you'll be happy. But this one is different. And if we normally ask these type of questions, not the one that you see. So this is the Grignard, right? So you got the double bonds here, but doesn't really matter. That doesn't matter. This is the carbon that's become the nucleophilic because that's the bound to the magnesium. That's the Grignard. That is going to make an attack to the carbonyl, as we see, right? So this makes an attack. This makes an attack there. You're going to have this electron pair to go to an oxygen. You're going to get an alkoxy groups right here. Same as before. So it's exactly the same reactions. Nothing surprising. What we have done before, at the end of the reaction, you're going to protonate it, and that's it, right? But that is not how it goes. I hope that some of you find the differences of this reaction compared to the previous ones. The difference is, this is not an aldehyde. It looks like an aldehyde. What it has on the other side are toxic groups. This is an ester. This is the one with the living groups. This is the one that told you that you are going to be asked in the test, but it behaves different way, all because it has a living groups. So let me remind you, that's an aldehyde. This one and that one looks very similar, right? You got the carbonyl here, you got the carbonyl there, hydrogen here, hydrogen there, alkyl chain, almost same, but they're different. I want you to see the differences. I want you to recognize the differences. This one, when they react with the same reagents, this one makes an attack, make an alkoxide. Obviously, there's nothing else is going to be done. You pick up a proton, and then you get this alcohol. That's what happened with an aldehyde. So this one, you make an attack, becomes an alkoxide. That's exactly the same stage as that one. So if you're thinking about protonating that one, then you are going to the wrong direction. You need to remember that it has living groups. So what happened was these electron pairs are going to come in. You're going to remake the carbonyl by kicking these ethoxy groups out. That's what the living group does differently. You kick the ethoxy groups out and then make a ketones. If you write that as an answer, still wrong, because that is not safe in the Grignard. Aldehyde, which is the same as that one, almost same as that one, is going to be really easy time to go in for another reactions. So another Grignard, going to make an attack to the aldehyde, you get an alkoxide. Now, this one doesn't have any living groups. Now everything's a stay like this until you pick up from the water, then you get these products. So that's what makes the difference is with the carbonyl with the living groups, with the carbonyl without the living groups. The one with the living group is like an ester. Acid chloride is only 2 examples. You get to see more later. Right now, those 2 examples are going to be even even enough headache, so we're not trying to deliver you more. But later on, you're gonna see other carbonyl which will go through the same way. But the ketones and aldehyde don't have a lipid group, so once it makes an attack, everything stops, it's gonna get protonated in. That's the only difference. Yes.
So what difference does the excess of the Grignard?
So that's the basic point that it's gonna be reacted twice. So that's why you need more than one equivalent.
Okay.
So that's one reaction is gonna make an aldehyde, second reaction is gonna make it out. So that's why we put an excess there. But sometimes we don't even write that. So that means enough reagents of presence.
So if we were given like that starting point, that product, and we needed to write the reagents, where do we need to write excess?
Even though I didn't mention excess, you should know that there's enough amount of reagents there. So if the reaction is going to happen twice, then you gotta do it twice. Even the excess is not shown. I know some people are looking for this Q for doing these reactions, but we don't normally put this excess because that's already giving up the hint. So so that's the thing. So you're not gonna probably see the excess. I'm just putting it there because it's actually used twice. But actual test question, you're not gonna see excess there. If it will react further on with it, then you should expect there will be excess of reagents available. But keep this reaction, even the excess of this reagent available within that one, it's not going to be used twice, right? That's going to be used only once. So anyway, so I hope that you see the difference between these two. This is a question that you will definitely see in the test. Every year we always ask. And look at the test three. I put it up as a sample test. They always have these type of questions. All right, the next one. Next one's a pretty simple in a way, but of course, there's a way to make it difficult. I'm going to show you later. This is an epoxide, right? We talk about the Grignard can open the epoxide. So the first step, combinations. The ether is just a solvent. The Grignard reagents are more stable in ether. That's why ether is just a solvent. So you don't even need to put an ether there. Just combination is a reagent here. That will insert between the carbon and the bromine, so you get the Grignard reagents. And that's the one that attacked the epoxide directly. So when that makes an attack, you got two carbon added there, and it becomes an epoxide that will pick up the proton in the third step, it becomes an alcohol. So in the end, you got two CH2OH was added to where we started, right? Because the epoxide is two carbon chain, those two carbons are coming from the two carbons of the epoxide. So that is a pretty simple question in case you know how the Grignard works with the epoxide. But let's talk about next level. This is an epoxide, that's an epoxide too. Water crystal structures, if these reactions done with this epoxide, not with that epoxide, the water crystal structure. Well, Grignard will be made the same way. This Grignard is going to make an attack either this carbon or that carbon, right? Which carbon is going to make an attack? In the case of acidic condition, you keep seeing it happen to the more substituted position. But if you're going for that carbon with a Grignard, it's wrong because the Grignard happens without protonations. It's a purely nucleophilic attack. So steric hindrance matters a lot. The word the Grignard makes an attack, less substituted side. That's the one that makes an attack. And then this carbon is bonded to the Grignard, this method, these groups, that groups there. And then oxygen is going to pop out as an oxide, pick up the proton. So if you think about this backbone, it's same, but the thing is where the methyl group is going to be hang on. People make a mistake where the methyl group is going to go. If you make that one attack this one, methyl group is going to be here. If you make an attack there, methyl group is going to appears there. So position of the methyl groups is telling us how you use the Grignard. And that is what we're looking for when you're writing an answer.